Hey there, it's Workbench or Workbench Quagmire back with day 79 of our Free Code Camp Python certification in 100-ish days. Today we're going to undertake this implement the selection sort algorithm lab. So let's get started. The selection sort is another popular sorting algorithm taught in most computer science courses. This algorithm works by repeatedly finding the smallest element from the unsorted portion of the list and swapping it with the first unsorted element. It begins by selecting the minimum value in the entire list and swapping it with the first element. Then it moves to the second position and finds the smallest value remaining in the unsorted elements and swaps it. For the second element, this process continues, moving through the list one element at a time until the entire list is sorted. Selection sort results in a quadratic time complexity in the best, average, and worst case scenario. The space complexity will be a constant big O of 1 because the sorting is done in place and constant amount of memory is being used regardless of the size of the list. Fill the user stories below and get all the tests to pass to complete the lab. So our first story. So as always, we need the function selection sort. Selection sort function should have one parameter that represents a list of items. So our array list or array. Your selection sort function should take a list of sorted items in place from smallest to largest. Should sort the items, right? The selection sort function should modify the input list in place and return it once it's sorted. Your selection sort function should follow the selection sort algorithm, swapping the smallest element from the unsorted portion of the list with the first unsorted element. And your selection sort function should not perform any unnecessary swaps when the smallest element is already in the correct position. Your selection sort function should not use either built-in sort method or sorted function. Okay. Alright, I had to look this up on the internets because I don't know what we're doing here. Because I was thinking I'd use like the min and find the min and then find the index of the min and put that to the first and just basically call that function on the list over and over again. So, but apparently that's not how it's done. So apparently it's like a nested loop, nested for statements. So first thing we need to do is determine the length of the list so that we can loop. So length of the array, and then we have a for I in range of it's n minus 1, so it'd be 9. Then we need to find the minimum index. Of course, it's going to be whatever we haven't looped over yet. And then for our next loop, we actually go I plus 1, so we're looking at the next item, it looks like. So we'll start with the 0th item. It's probably gonna throw all kinds of errors, but just put this in here so we can kind of see what's going on, hopefully. Any issues? Something was never closed. There we go. Okay, we're not returning anything yet. I think we end up returning the array. So let's see what we got working here. This one we got 10 tests and we're passing 5. Not passing any of these tests. And should follow the selection sort algorithm swapping minimum values. Alright. So in this for statement, what we're going to do is if the array j, and so say we go through here 5. What's first? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of our array will be 9, and so we're going to say from 0 to 7, 8. 8. We find the minimum index, which is going to be 0. And then for j in range, I should be, this one will be 10, which actually the range will be 0 through 9. So this will be 0 through 8, or 0 through 7. What it's doing? So we can do this. Yeah, it's going to be 0 through 7. And the other one will be 0 through 10 or 9. That'll be 9. Okay, now we have to see if the item at j, which will be 0, so this is 5 in our test case, is less than array min index, which is 0 at this time. And the new min index is equal to j. So what is our min item? Our min item is 3, so it's at the end of the list. So when we go through here, we go length is 9 for range 0 to 7. Minimum is I, so 0. For j in range 0 through 10, or 0 through 9, sorry, I'm getting that wrong. If the item at 0, 5 is less than the item 5, which is not, then the min index will be j, which would be 0, but it's not. That test fails. So if the min index is not equal to I, so now we're back in our main loop. Then swap the found minimum with the first unsorted item. So I equals array. Oh, this is doing a swap. So our test, which is this one here, should return 3, 5, 12. It's not returning any of that. So we got a mistake in here somewhere. Huh, there we go. Scan the unsorted part of the list to find the smallest element. So this is why we're going from 0 to 7, and this was going 0 to 9. We're actually starting at 1. So when we look at our array, we have a 9, we start at 0. We go down here and we say, okay, if the item at J, which will actually be at 2, second item. So if 16 is less than array minimum index, which is actually 0, so it's not, then the minimum index is J. So basically it would say, okay, well, if 5 was here, it would say, well, the minimum index is 1. But this isn't true, so we go down here to our if statement and we say, okay, minimum index is not equal to I. So remember, I at this point is 0, but it is in our case. It's this time through it's 5, so we would just iterate back through and go to element 2, which would be 16. So this would be 2, this would be 3. And so if the item, if 16 is less than 99, which it actually is, so we don't have a change in this until we get here. So, but then when it finds that the minimum index, it swaps the values. So we go, okay, okay, okay. Let's go to swap. It's interesting. See if we pass. We do. All right. Well, there we go. That was our implementing the selection sort algorithm. Thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.